All right, we'll go ahead and get started. There's a lot of content, so I want to make sure I've got enough time to get through it and also leave time for the setup for the next folks that are going to present. The talk is, it doesn't have to be STUXNET, attacks on common ICS systems. The meaning behind that title is there's a lot of focus that's getting put on, higher profile attacks targeting industrial controls and SCADA. But I come from the Detroit, Michigan area, and we have a lot of automotive and we have machine shops, and there's all kinds of places in there where they have these systems, don't have the budget to defend them, and so those organizations need to be looked at as well. So that's kind of what this is going to involve, targeting that type of environment. I'll go through a quick introduction first. Yep. So you see me. You can find me on Keybase, X, pretty much all the socials. I am a principal consultant at Optiv Security. I've been there almost 8 years now. Primarily adversarial simulation and consulting. I don't get a lot of IoT work. Once in a while, I do. I have gotten to do some ATM work, which is cool. So shout out for Mr. Birch for paving the way there. How I got started though, back in the 80s. I mean, I'm an old guy, right? So I think it was 5th grade, 6th grade. There was one computer per school in the district. I would stay after and write little text adventures on I think it was a Commodore VIC 20. So that if there's any older folks in here, that'll tell you kind of how old I am. Got into my teen years, war games came out, got hooked, got into the scene for a while there, doing some cool stuff. Shout out Crazy Wizard and Maelstrom, whatever you guys are doing now. Anyways, after that, I didn't really stick around hacking, so to speak. I moved into other things in my life. I started working in a place called Spina Electric, and that place, small organization in Warren, Michigan, and they do electric motors, drives, controls. So that's where I kind of got introduced to this. I really never did any of the installations there. I did other things in there. I was an IT administrator for them. I did, however, crawl underneath some presses and mount transducers and things like that. So when we talk about safety instrumentation systems later, that sparks a really good thing with me, because it's kind of a weird feeling to be under a huge press, right? And this thing could fall on you, and you won't even know it. It's going to be so quick. I do have a degree in cybersecurity from Walsh College, local college, very cool place. They blend cybersecurity as well as business. So a lot of folks say college isn't needed. I personally like that track because being able to understand profit and loss sheets and things like that. So when you're talking to clients, you have to be able to speak to them in those terms, right? So really cool school. And then finally, since I'm an overachiever, I think I'm a reserve deputy with the local county sheriff's office. I've been there 14 years working with their cybercrime unit. Our mission there, of course, is child predator apprehension. We also do education in the schools. So a lot of times we'll go in and give the kids, presentations on what's going on, what's the new threats they're facing and things like that, as well as bring the intelligence we get from the kids back on what they're doing. So it kind of works as a partnership there. Really cool gig. Crazy stories, as you'd imagine. So the purpose of the talk, again, kind of get smaller organizations, medium-sized organizations, thinking about ICS security. Usually it's just something that some manufacturer or vendor came and put in for them. So, want to get them to start thinking about that. Illustrate what an attack will look like. So I am going to go through an actual attack. I wrote a couple pieces of malware to do this. Again, when I put this talk together, it only was a matter of like 3 weeks, 4 weeks. And like I said, I haven't really installed ICS equipment. So my point is, if somebody can just out of curiosity put all this together and actually do this and perform a ransomware attack against some tanks, imagine what nation states could do against a small company, right? Throughout that, we'll look at some opportunities to identify those attack patterns and mitigation. And then, of course, try to focus on that before it happens, right? So general awareness. Target audience, we kind of went over that. Anyone that does have an interest in ICS doesn't have. I think it's really fascinating tech, even though I don't deal with it all the time. But I really like how things are positioned together to physically control and build things in space and in the environment. So ICS primer, just so we can level set and kind of get some terms in this space, there's a lot of acronyms like anything else that we deal with in our environment. So I would kind of want to get a little bit of that. Some of it is not super clear to understand. And I may call on you to kind of clarify specifically, because she works that space a lot. But yeah, we'll get into that. So what is an ICS? An ICS is really a system to build and produce an output, right? So that's what these industrial control systems do. There is a difference between OT and IT, right? They always work together in concert and marriage to make things and get processes done. But they are a combination thing. So it's not just if you say ICS, it means one box on a wall. There's other things that are encompassing it, right? There's different types of setups. So distributed control systems, those are more like local within one site. And when you say, and a lot of people will use the term SCADA as like a general term, but SCADA really is like multiple sites put together is really what SCADA would kind of focus on. Energy management systems, as that's pretty self-explanatory. It's mostly focused around energy and transmission. Process control systems, that's like the entire flow of how something gets done to produce an output, whether it's a widget or whatever. And then the all-important safety instrumentation systems. Those are obviously super critical. There has been attacks recently that targeted the safety instrumentation systems. So you can't really shut things off short of cutting power to the site. And that's not always an option, right? You can't just shut off a nuclear plant and just expect it to go cold. So these HMIs are the ICS systems. Again, it's more components, lots of acronyms, but the human interface, most folks probably have heard of that, the HMI. That's really when you see the operator controlling the screens, doing input, being able to control the devices within the process system. The one on top is actually a 40,000 volt electric panel we had at Spina, and that can ramp up huge motors, put them on a dyno test bed and spin them up, and we can control those variables. But that's kind of what it looks like. The screen doesn't show a whole lot of it. The PLC, of course, those are actually controlling the devices. Those have different types of protocols. We'll get into that here in a second. But generally, that's going to take the data from the HMIs and the RTUs and actually control things in physical space on those equipments. And they are like a combination of sensors, actuators, motors, things to say, how is this physical equipment running? What's it doing? And then things to make it change how it's doing that. This is kind of an easy way to understand it. A lot of these protocols are old. Some of them are based off of really insecure things. We're going to target Modbus here because there really isn't much security in there with that. It's not authenticated. You can easily hijack that. I'm going to do that here in a little bit. So what these kind of look like, and we'll get into the actual recommended model in a second, but what you'll see a lot of these places put these together in is similar to this, right? You have your corporate environment. That's the one enclave. There's ERP, your normal business stuff, the accounting systems, and all the networking that goes into that. Then you have the supervisory environment, and that's what it sounds like. It's to make sure things get managed. That's getting into the ICS space. Data historians to look at the logging, see what has transpired, as well as analyze that for efficiencies. And then SCADA servers, if you're running in a SCADA environment with multiple sites, that thing will basically open up the management for those two remotely. And then finally, the production environment, that's where you're getting the physical space movement, getting those PLCs to move and things like that. So this is just a really high overview. I've seen it a lot of times in our areas, in smaller businesses and things like that, where they're just flat networks. And that's super ugly if that happens. There's not or even if it's just a small enclave separation that can be bypassed. Again, these folks aren't in the business of ICS. They're in the business of building, screws or metal output or something like that. They don't have the expertise to do that. So they rely on these vendors and stuff. So there is a lot of regulatory and recognized standards out there that, suggest how they should be managed. As general frameworks, NIST has a bunch of things. They do have 800.8.2, and that's specifically focused on ICS systems and security thereof. Industrial control automation systems, ISA has stuff. NERC, SIP, that specifically is focusing on critical infrastructure. So there's all these different, and some of these designs are overlapping, right? They have some of the components for the same things in different terminology or different slight design, but they're all trying to achieve the same thing and provide a safe ICS environment that can be relied upon. So the pipeline one, TSA, that's, of course, controlling gas. Any type of liquid or hazardous liquid would be under that one. And then CISA has their stuff too. So lots of guidance out there. But again, unless you have somebody that's skilled in this and the budget to put these frameworks in place, it's hard to do. So this is one of the most popular recommended models. I think there's a few others out there, but this one's pretty good. Purdue, it's been around for a little bit, and it breaks things out into different zones. So as you go through the different zones, obviously the levels, enterprise, similar to that chart we just showed, it kind of breaks it down until you finally get to level 0, the process, which is the actual physical things that are moving in space. Doing these things and putting it all together in connectivity, you can't make rapid changes, which is another security issue. You can't just, hey, there's a firmware update every other couple months, which most of these equipments don't get a firmware update even built by the manufacturer for a long time, if ever. But then you have maintenance windows, right? You have to, up in Michigan with the plants, they're always doing their maintenance windows around holidays. Well, we can't wait on some of these equipment things if it's super critical to wait till next Christmas to do it. So that's another challenge that they experience up there. So some of the protocols, and there's a ton of them. One of the first ones, though, RS-232, 485. A lot of folks in here are probably, familiar with that, with RS-232. Really short haul and long haul between sites. That's where you'd see that. Modbus, which is what we're going to focus on today. Again, raw messaging. There's no authentication there. From a security standpoint, there essentially isn't any. There is encryption and checksums and broadcast suppression in some of the implementations, but they're kind of iffy on that. It operates at the application layer, the OSI, and then it has a concept of client servers, and they used to be called slave master, right? Yeah, slave masters. But now they've changed it, client server. So the client would be essentially the PLC and the input coils, which we'll talk about in a second. Those are the servers that actually would control the space. So distributed network protocol, that does have some security things in it. It's mostly found in primarily in water, though, and maybe electric in some spaces. Again, application layer. I don't know a whole lot about SIP, but from what I was researching, again, I don't do this all the time, so this is all just me looking it up. It is vulnerable to denial of service, though, and I will use that against Modbus as well here in a little bit. BACnet, I've seen that. Personally, doing pen tests in HVAC systems and fire protection. Funny, good story there, but I won't get into it about foreign IPs getting into senior folks' homes and controlling it for whatever reason. Profibus and Profinet, we did see a lot of that in the controls that Spin Electric would implement. Again, I don't know a whole lot about those, but whether it's serial or Ethernet based, just another protocol. There's no authentication there either, which most of these don't have that until you start getting into OPC, UA. That does have it. That has some secure channeling. It has signaturing and digital certificates for the transmission. So that one is kind of the one that folks probably should go to based on what I could find out about it. But that does come at a cost. So that one, a little bit slower. Ethernet IP is a little bit faster, I think is how that goes. So how these talk to each other, coils and inputs. The coil really is the thing that's going to make something physically move. Okay, the discrete input, that's going to be something that makes that thing move and tells the PLC to do it. So that would be like push buttons, switches, levers, things of that sort. Then there's registers. So you can have an input register, and again, read only, so that you can send data to it, and then holding registers so you can write to it. So it gets a little confusing. Nonetheless, these are all different 1 byte sets that you can address. The program that I wrote is going to do that itself. So this is kind of what it would look like. This is within OpenPLC or Factory IO, which is what I use for the simulation environment. You can see on the left side, those are inputs. That's where you're going to like start button, stop button, things like that. And then you'll have those valves that would actually get activated based on the coils that those are setting. So, and also Modbus has function codes that you can do a lot of different things with. In this case that I did, I used the write multiple coil method to kind of start firing things off at random to these tanks. But there's a lot of different functionality there. I won't get into every single one of those for the sake of time, but so this is what it looks like under Wireshark for Modbus. You can see it's plain text. You do see the decode from the packet structure of the bits on what might be set for the coils and the registers. And as that comes through, you can see it in plain text from any machine that's on there. There's no like encryption involved in it or anything like that. So from an attacker standpoint, it's easy to kind of start seeing that traffic. I haven't attempted to man in the middle it yet myself personally, but I know it can be done. So that's an attack method as well. And how these operate to control things is using something called ladder logic. It works from top to bottom, left to right, and it's really efficient in being able to control these things because it can only have a certain state at a time. There's no such thing as like multi-threading or multi-process or anything like that. They're all working through at one set time frame, and then as you change the switches, it would recycle to change whatever it's doing. This is one of the example logic ladders that I put together for this demonstration, but it didn't take me too long to figure out. Again, had never written ladder logic, and within like 2-3 days, I was able to put stuff together to do it. And again, if like, people that are nation state attacks where they've got tons of money, imagine what they could pull off, right? So in speaking of recent attacks, there's a whole bunch of them. I'm sure everyone in this room has heard of some of them in some form or fashion. The first one that I can remember kind of personally being a big thing was the Aramco attack, and that one specifically targeted those safety systems. So manipulating the safety system where you cannot disconnect this thing in its intended manner. Again, if it's remote, if you have to physically go out and do this, most of these are not that set up to where it's sitting right next to an operator. So ugly thing there. We've all heard about the Colonial Pipeline attack. That one was focusing on IT, but because of the breakdown between that reliance on IT and OT, it caused the OT outage. So it wasn't specifically targeting the OT environment, but as a result, it did shut it down. So that one, the pipeline for the East Coast was affected of the U.S. If you don't remember, pretty nasty there. Volt Typhoon, we start seeing these things ramping up and seeing more APTs trying to use them. This one targets the United States critical infrastructure. That one, they don't really have their own malware, so to speak, but they do a lot of living off the land to affect the OT environment. Again, they're both dependent on each other, right, to run. So if anyone was listening to the panel the other day and they were talking about secure your ground station first, that's because those ground stations and windows and things like that are controlling those things in space. Similar idea here. Pipe Dream, that one had specific targets of Schneider Electric and Omron PLCs. So they were purposely going after certain things with that. It does have a really interesting, almost like I would to term it like a Metasploit framework for ICS. It's kind of cool. They have different modules and there's a lot of different functionality within it. I've never tried to procure it and mess with it, but you start seeing that advancement now as it's going through. And of course, the Ukraine attack, that's bringing a lot more things into play. We've seen multiple occurrences where things are being targeted in Ukraine from primarily Russia, since that's who they're technically at war with. But a lot of different opportunity there for threat actors to use that to manipulate a conflict. right? Not just ransomware or try to get money or cause a problem. They're trying to use that along with their other kinetic activities. So impressive, sad, but impressive on that progression. And it's been a lot of power like targeting that they've been doing there. And then Cyber Avengers, the Iranian attack group, they're starting to target U.S. things, and again, Unitronic PLC. So again, more specific, because most of these PLCs and these controllers are, proprietary. They have their own in function codes. Yes, they might talk in Modbus or Profi or something like that, but the firmware inside of them are pretty proprietary and unique. So they're starting to actually go to the firmware level, like Stuxnet did, or allegedly. But that's where that is. And yeah, the app's default credentials is still a thing. Like it's even mostly in ICS, it's almost like print admin, but on this equipment, which is horrible to have going on. But if you have a small organization and you're not, have a full plan and full framework in place, whoever installed it, and he's installing 1,000 of these things a year, he might leave the default cred there because you're relying on third-party vendors. So those recent attacks, they do have a lot of things in common, though. They have their size is large, the notoriety. Some of the groups want to do it so that they're known. Like the Iranian group, they really want people to know they're lethal at doing this. And then the value. So even though the pipeline attack wasn't OT focused, it did cause a lot of dollar impact, and so they took notoriety and the result of that as well. So. Again, like we talked about, geopolitically driven, trying to, coerce or impact foreign policy because they have this weaponized is a thing they're trying to do. And of course, ransomware too. So all those are huge, but the smaller environments don't get any love. So there's just not enough money there. So the attackers, we're starting to see that going after these smaller organizations because they can still pay some amounts when they have to, right? And then the attack surface is increasing. So when you're, years ago it was all on-prem, but now you're seeing that a lot of things are getting hooked into Azure, different cloud-connected industrial devices and things like that. If you think about your home stuff, getting up into the cloud to manage it, your cameras and things like that. Some of this is starting to do that too. Rockwell has their own solution. Siemens has their own solution to do it. So we start seeing that happen as well. Again, more attack for the bad guy. So just kind of an example, I think I pulled this off yesterday from the hotel room, but at the time, port 502, which is what Modbus operates over, for almost 4,500 devices in the US reachable from the internet. And, I look for 502, and then I also look for it to broadcast a unit ID because in Modbus, that's usually how it gets addressed within the protocol. So, that's things that aren't like non Modbus running on 502. These are actually Modbus devices. So 32,000 around the world. Again, Modbus is inherently insecure. Just paints an ugly picture of a lot of opportunity to mess around, right? The E1 router on the side there, that's an industrial router, provides connectivity. Again, most of the time when I've seen those, they get installed by a third-party vendor, and they have just a scripted configuration. There's definitely opportunity in this space as well for supplier attacks. And MITRE does have a matrix for it, which is cool. I was talking with one of the NASA JPL dudes the other day, and they were, at some point, the space area is going to probably have to get something like this as well. It would be neat to see MITRE get into the satellite and space area with the MITRE matrix. But it has one. Pretty cool information there for threat hunts and stuff like that. Okay, enough of that crazy me pretending I know what I'm talking about with protocols. Let's get into the attack, which is a lot of fun. So this attack, hypothetical, it's ransoming actual OT environment stuff. I wrote code to control those PLCs and things to ransom it. It does have C2 callback. It's encrypted. It's using AES. A couple other things we'll see when we go through it. It's assisted by IT, which is any of these things. Usually they're going to have to breach it somehow. They have to get into the environment to at least start touching these segments. The initial breach is a phish. I have a custom app that I wrote there to get the payload through. looks like a Teams update. It's nowhere, it's not a Teams update. Um, it works really good. That's my go-to kind of now when I'm fishing is I'll find out what the environment uses and I'll write in C# Visual Studio, create a mock-up that looks just like that and operates with the buttons and everything, but really it's launching my payloads behind the scene. It's been really effective. I don't need domain admin here. This is just user space. My compromised user, I'm going to use that as my foothold and perform my ICS network discovery within the C2. And all the things here I wrote in Golang, except for the Teams update. Everything else I wrote in Go. I just like it. I tried writing in Rust. I hate it. I don't like Python either. I know it's good stuff, but I like Go and how it feels. Everyone has their favorite, I think. So um, the PLC denial of service, that was written in Golang as well. So when you want to control these devices, you have to knock out what the legitimate PLC is. So I kick that out and have my own ladder logic to take over. I already mentioned that. Yeah. So the way the malware will behave is it does its jittered check-ins with its C2. If it fails comms, like they just like disconnect communication or try to isolate it, then it automatically knows to detonate, and that's when it'll actually blow things up. So it has those types of safeguards in it. I could write, so I do have it set up to be persistent, and I set persistence as well. So this could be, wormed and moved out throughout the environment to make it even worse. But again, it was a demo. I don't want to get too evil. Start. So what we're going to target is a vacuum pregnation system, a VPI, and this is from Spina. They're really cool people. They let me kind of come in there and just take pictures. The stuff that I'm doing here is not anything you would find in their environment, so please don't try to Google them and attack them. You're not going to find what I'm doing here. But this is pictures of the thing. It's got the HMI. And what the VPIs do is it protects the motor windings from corrosion, and it seals them in. Super important for motors. If those start getting jittery and start vibrating, you're going to run bearings out. It's going to burn out. So what this will do is protect those windings. There's better heat transfer. Some of these things are like a 3,600 RPM motor moves pretty quick. So you want to keep the heat down as low as you can. Most motors, you'll see them with fins. Those are actually basically heat dissipation on all of them. It also reduces that chatter in the coil, like I was talking about earlier, and just make it overall efficient. So the way how it works is you take the motor, dip it into the tank, screw everything down, set all your stuff. It will take the resin that's in the big one, push it into the tank, and then like literally push that into all the crevices of the winding. Pull that out, let it dry up, put your motor together, you're good to go. So it's a process, but these are under a lot of pressure. I don't know what the PSI is, but they're a lot. It's a lot. So the tanks kind of fit in with OpenPLC or Factory IO. I don't know if anyone messed with that, but I know you did, Anna. But they have some things in there where you can simulate tanks and conveyor belts and all kinds of cool stuff, and it fit kind of the same attack. So I just used tanks. I did use OpenPLC for the simulated PLC to control the Factory IO equipment. We'll look at that here in a second. Open source project, really cool maintainers. If you want to monkey around with PLCs and building your own things, you can combine these two and build up full-on, ICS environments. It's really slick. And OpenPLC is free because it's open source. Factory IO, you can get a trial. I think it's a month. Yeah, it's something. Yeah, it's. And then I purchased it because I use it a little bit now for this stuff. But really neat platform. This is a closer look at what the HMI might look like. You can see from the operator standpoint, they would have the start process buttons. They can see all the critical things within the pressure readings and different registers. Those all would come from that PLC feeding that stuff back into the HMI with those registers that we showed earlier. So that's how it would get it. Some of them do have integrated like sensors where they're kind of connected to, but they're not part of the PLC. Those transducers that I talked about mounting in the presses, those were like that. They still were being used to monitor things and control it, but it wasn't technically part of the PLC directly. This is a atypical attack setup. This is what I used for this. Cloud fronting, lots of cool ways to do that. That's a whole different talk. Trying to hide your C2s and set up, burner C2s and stuff like that. There's a firewall in here. Again, it's a small organization that we're targeting, so the segmentation's not very good. And again, I've seen that quite a bit, whether pen testing or going into some of these other shops and factories. It's just not segmented well. So that's what it kind of overall looks like. This is a huge motor here that's sitting on a test stand, which this controls, which is the test panel. So the initial breach payload, again, I built it. I'm going to show you a quick video of it here in a second. Looks like Teams, but behind the scenes, I didn't obfuscate any of this stuff. Threat Hunt would find it in a heartbeat. However, just for ease of legibility to demo it, I wanted to keep all the code the same as far as modules. So really all this thing I want this thing to do is run a DLL that I have packaged with it. That's all I want it to do. I set a specific entry point within the DLL so that it tries to avoid some other type of looking into it and just calling it blindly, that it won't be able to do that. It also had mutex set in it, so it would not fire off more than one time on the same platform. That gets critical because you don't want things fighting with each other if you're trying to ransomware this OT equipment. It can only talk to one thing at a time. So does some thread sleeping, fires it off. Yes, I did use a popular and effective EDR, and it got past it doing this with the combination of how I built the DLL plus creating this thing. So my fish, again, I always make it as accurate as possible. The company I'm attacking is Vanguard Motorworks. I make it, high importance. This needs to be done, or you're not going to be able to have meetings. You're not going to be able to talk. You're probably going to get in trouble. So that's how we always create them, right? If you've done phishing, you got to create a sense of urgency, and that's what we did here. I have that going to an Evil Jinx portal. I've got another way to get, there's a way to get things to where it can't look behind into the Evil Jinx portal. If you put captchas in front of that, it doesn't, the systems right now do not know how to solve the captioning. So I put that behind a particular captioning portal when I do the fishes, and those have worked quite well to keep them from getting burned. So just a super quick demo. I will not do live stuff. I was talking with Anna earlier. I'm like, I don't trust it. So user gets the email, they download the package. Okay, looks like Teams. Everything looks like Teams. It's even saying it's got a update thing. They don't have to click the update Teams. That payload's already been fired. So fire it off. Beacon comes back. However, and I was talking to someone else, I think last night about this. Yeah, even though it did what I wanted to do, I don't want them questioning it. So I still let it do its functionality. I still let it, give it the thing saying it's been completed. Okay, I'm done. So I've got my beacon. I use that same method quite a bit. Works pretty well. Of course, Cobalt Strike, a lot of people know it. That's why I showed it. We use a lot of other C2s, but since this is public, this is the one I used. First thing I want to do is get a lay of the land in the environment. I want to see, what is there? What can I get to? I don't know there's ITS or ICS or OT in there yet. From an attacker standpoint, I'm just kind of looking around. What can I do with this? My goal is to ransomware, though. I want money. So set up a SOX proxy so that I can execute my tooling without being scrutinized on the EDR. Really, all it's going to be looking at then is just the network traffic as it goes through my hot point. And I want to see where the DC is at least one DC. There's a couple ways to do it. What made it super easy here, just did an honest lookup. Don't do that. Who am I either? Because you're going to get burned. But from a demo standpoint, that's how I did it. So get the DC. I like using a cool tool called Vibe. One of our buddies kind of built this when he was at Optiv, but really cool tool. What's cool about this is it'll pull all the LDAP Active Directory data down in one burst. So you're not making successive calls to domain controllers and thereby opening up the opportunity for Threat Hunt to see you. Once I have all that data, I can go through and start formulating, what groups, users, policies, descriptions, SPNs, all that stuff is already offline, and I'm looking at it. I kind of refer to it as a poor man's bloodhound because it really is in that thought process of getting that data and be able to place it together. Again, open source, you can find it on his GitHub. But anyways, we look through the data and we see service SCADA. Interesting. If I want to make money, that could be cool. Password doesn't expire like you see a lot of times happening with service accounts. So we're going to check that out. So look it up, and it says account for VPI tanks. So I'm pretty sure now that there's something in there for an OT standpoint. Um, I would always look for 502, just because it is in a lot of places still, even because it's so old. So use my C2, did some ARP scanning, looked for 502 specifically. I found 2 devices there. And then I kind of look a little bit further. And you see, I'm doing all this through SOX proxying, right? Again, so they're not looking at me from an EDR perspective, and I can use whatever tools I want. When I do Nmap this, I see that it's running a web port. I'm like, okay, cool. That's always neat. So I'll look at it, and then it tells me, okay, open PLC. So now I know what's kind of controlling that. It would probably be something else that's got a web interface to control it. But again, it's free. It's a good thing to use for a demo. So I see open PLC there. All right. So now I kind of have an idea what is controlling the devices. This is what looks like when it's actually just not being attacked or anything. This is what those coils and things are doing. So as you hit the start switch, you see the coils, or the indicators there, and you also see the registers and coils activating. So it's telling something to move in physical space. And you can see the tank doing that. If you hit stop or the empty, it's going to decrease it. Again, changes the coils. So it's doing all those things. And this isn't me doing it as an attacker. It's just me showing you what it would look like as that stuff is getting controlled. Okay, cool. I don't have access to the HMI though. So how do I know what kind of registers and things are being set within those Modbus calls? Well, Metasploit has one built in. There's other tools out there. The NSA actually built one where you can look at packet flow and it'll pull out that stuff. That's open sources too. I'm trying to remember Grasshopper, something I can't remember. Anyways, there's ways to find out and try to get a study of what those positionings are. So if you start watching it over time, you can kind of see those registers getting set and what's happening. So again, it just solidifies for the attacker, okay, there's definitely something broadcasting there and there's something getting set and it's being used. So the ransomware that I wrote to start controlling this stuff before we actually do it, I wish PowerPoint would allow us to have text or code blocks, but I guess not. So it's going through. I set up a temporary domain for it to do a control. Essentially, what it is encrypted JSON with AES salted, um, and then the command structure. I'll show that in a second. But it's making calls to the server to get its payload through. There's TLS doing that stuff. Let's just whip through here. Decryption, blah, blah, blah. Great, fun. So now we get into the tank cycling. So now we're going to start setting those actual coils. There is a Go library that has Modbus support. So that's what I used here. Super, super well done. Highly documented. So you can kind of figure things out. But what I'm doing here is I'm setting different min maxes for different things to then randomize on those coils and registers. So you can see they're all fill coils. There's a command all tanks, which if I want to command all of them at once, which I do, I can then feed into that function code and say, empty them, pause it, fill them, things like that. I can also target specific tanks with it. Again, just by doing those different, using that write multiple function code within Modbus's protocol is how this is done, to be able to do these all at one time instead of trying to constantly hit each one. And really my goal is, when this is just not to blow it up, my goal is to just cause chaos by filling these things and emptying them and filling them. And people are freaking out. Like, I've already cut the PLC off. I've cut the safety instrumentation off. There's no way for them to stop that other than to shut power down to that segment of their building. And again, you can't always do that. So again, hypothetical, but an interesting way to look at an attack path, how it might go. The comms check, it's looking to see if it can actually phone home. If it cannot, it's going to immediately go to detonate mode. And then I've seen in other activities, I've seen him, and there's actually a talk by Aaron Packett coming up after this in this room to talk about using emojis as command and control in cryptography. So I'm going to stick around and check it out, but it was totally coincidental. That's what I used here because I've seen it to control bots before. So I'm like, all right, I'm going to have my encrypted stuff use emojis. So maybe it'll make it harder if they are somehow able to break that decryption. So you see little emojis, evil, it's kind of basically turning it on. The explosion one, we kind of know what that's going to do. Pause it, extinguisher to put it out, and then kill it. Basically get rid of all those payloads that are running it and kill them. So that's kind of the code super quick. I wish there's a better way to do this in PowerPoint, but anyhow, this is what it looks like when it's decrypted to the ransomware C2. You can see that the JSON gets decoded. It gives it the instruction code. It's telling it which node to target. And then you see it doing all the different detonations and emptying tanks. These are debug messages I had built in that I built into the ransomware C2, just so I could kind of watch that. But I kept them in here for clarity. So the OpenPLC thing is really cool, really good maintainers. There's a lot of folks contributing to it. As part of this, I needed to break that PLC. I needed to denial of service it. If I'm on network, I would typically use HPing or something crazy because Modbus doesn't care. It's easy to tip it over. However, I'm trying to do this remotely through a C2. So how can I do that specifically with this product? And I researched that. I built malware that would actually do it. It's currently I'm working with them and they're working with me to try to get this patched. So I don't want to get into too specific of what it is. It did, and they did confirm it to be a 7.5. So CVE 2025-46613. Pretty excited to do that, to actually make it work, and going through GDB and looking at the code and find a way to break it. I have slides and things that I was ready for. We thought we'd have it patched by then, but we don't. So got to leave it at that. Really cool group of people there, though. This is me executing it. Again, using proxy chains because I'm remote. So I want to use that SOX proxy to actually cause a remote denial of service on a PLC, which is pretty cool. Just says the text output here when if my full code has what it's doing and what it's actually accomplishing. But you can see now it's totally disconnected. Hitting those buttons is not controlling that at all. So there's no way for them operators on the floor to do anything with it because now I can control it. And that's what I'm going to do next. So first thing we do here, we have our binary that we built, our ransomware in Go. We're going to put that up on there. We're going to store it in Teams because it looks like they don't really scrutinize that. I call it Teams update. Put it in the same directory. And then I set persistence with a registry key set. Again, this could be done on multiple machines and they would time up with the C2, but I just didn't have time to build it out that way. So that's the registry set. I execute it to get it fired off. That would otherwise fire at the next restart. Then I go back to my ransomware C2 and everything's hooked up. I got it activated. The command got issued to it. You can see in the output there, the JSON was retrieved. Now you start seeing all the things start getting nutty. So these are, they're filling, they're emptying, they're filling, they're emptying. I can imagine an operator on the floor being like, what is going on? And again, high pressure environment could be a problem. You start seeing all those coils operating, they're just doing random things. It stops, and then if they choose to not pay, or there's command, the comms get severed, it gets the detonate code. So that's what it's doing now. It's going to fill, overpressurize. You can see all the coils that are affected and what would control that being lit up because those have been engaged now with those bytes being set. And it'll continue to fill until it overfills. Again, you could shut the power off to this area of the building, but there's instances where you may not be able to do that. There's nuclear and things like that. I don't know why the sound is still on. I actually meant to turn that off. Sorry. Kind of made it feel hokey. I'm like, I'm just going to shut it off. Anyways, there's that. So let's talk about mitigation. I know it seems kind of goofy, but it's a really neat way to like put a concept that you hear in documentaries and blogs and stuff like, yeah, all that stuff makes sense, but what would it truly look like on the glass for a hacker to do it? And that's kind of why I wanted to build that out like that. So um, hopefully you enjoyed that part. So let's talk about mitigation, because if we're professionals, we want to make sure there's ways to fix this and point out things for the client. So it's just what we did that initial breach with a fish, had that fictitious, malicious Microsoft Teams update, had them run that so that we could get our C2, did some internal reconnaissance and enumeration to find those PLC things in there in the ICS space. Found that it was using Modbus, luckily for the attacker, because it is inherently insecure and easy to manipulate. So then we create that payload to do it and ransomware the folks. So from a mitigation standpoint, kind of go through the same phases, right? The external phishing, obviously you want to train your folks up on that. There's other ways, but I mean, really, you have to continue to train it. I hate getting my cybersecurity awareness training every year and having to be trained on phishing. However, there's been some fishes came through that target us, and we're like, man, that was pretty close. So you have to continuously train on new techniques and new things that are being placed in front of this stuff. Multi-factor, of course, you want to enable that. Evil Jinx doesn't really care about that. Its whole purpose is to capture those tokens from MFA, which I love. But you got to at least try to do these things, defense in depth, right, to try to keep this from happening. The malicious teams update, allowing applications to run that are malicious. One of the biggest things I try to recommend, and I know it's hard to achieve in an environment, is application whitelisting. It really stops a lot of attacks, not just this, but other binaries that should not be running. Maybe there's employees that like to run things they're not supposed to. It would stop that as well. So, and again, the training. Hey, why didn't this Teams update get pushed automatically? Why do I have to physically do this myself? Right? The employee should be asking that. From the C2 session, again, the EDR stack in this case didn't save them. It's a really popular, well-known EDR stack, but because we're super ninja squirrels, we have ways to get around that a lot of times. But you still, again, need to try. The baseline of normal behavior. Why would this person's box be doing port scans for 502? It should not even be happening. There shouldn't even be port scans in the environment for 502. Those PLCs and the equipment, they know what they're supposed to be talking to by configuration. So there shouldn't be a lot of bursts going on there. Monitoring logs, right? It's great to have them, just like backups, but unless you're looking at them and doing something with it, it could cause problems. So domain controllers, the LDAP thing, really the only way you're going to see that is that initial network activity for LDAP burst. I've never seen, and I've been in some highly secure environments where they're actively hunting me. I've never seen them see me do that. I've had them look for it. They never see it. So I'm not really sure what I would tell the client there other than try to look for it, but they can never see it. So the biggest thing here is when we start talking about the ICS things, though, is keeping your zones properly segmented. Again, smaller organizations, they don't even know about segmentation a lot of times. They're just hooking it up because they want to get it installed so they can start running it next week. So having those things segmented in proper zones and firewalling and down to the equipment and port protocol level is super critical. Monitoring those things, again, so you're not seeing a lot of port scans for those different protocols, needs to be done in those spaces. And then also, almost as important as segmented zones is, if you can, and it's super hard to do because a lot of this equipment's old, is to try to use those newer ICS protocols that have those encryptions and signature certificates and stuff like that. For a small organization, maybe that's something they can do, which is easy, but man, I can only imagine a full, energy site trying to do that stuff. It would be hard. We talked about the application whitelisting. Again, it still comes into play with the malicious ICS payload because that's what we utilize to run that from IT space, right? So it would have stopped that as well. Threat intelligence, if you have threat hunt teams or if you have a third party doing it, make sure that they are looking at the ICS intelligence as well, not just the typical network pen stuff. There's attacks like we showed earlier, always getting more sophisticated, that's coming out from these groups. So that needs to be inherently part of your threat hunt and your defensive capability and focus. The rogue server, we talked about the segmented zones. We didn't have to really worry about firmware here other than the fact that it's running OpenPLC. When that gets updated, the group will do an initial push to get that updated out. So, but same thing, like if you're running Siemens or something else, you want to make sure that if you can update the firmware. Super difficult to do in reality though, because of things that are dependent on that and what it might break. And then destruction of the equipment. Make sure the employees are properly trained in safety and emergency. When I worked at Spina, we had a train derailment right behind our building, and it had chlorine in it. And some of the folks there had no idea what they were supposed to do until we went out into the back and we're like, get your stuff out of here. You guys got to get out. So that stuff does happen. And people need to be trained for that. Obviously now they're trained up, and a lot of places I go into, when I do physical threat assessments, I ask them, do you have an emergency policy for if this thing blows up or this generator, is causing problems? The segmentation, specifically safety systems, need to have, if you can, secondary and tertiary controlling there, and the right procedure for the right people to immediately shut that stuff down. Patch management cycles are difficult. Again, like we said, a lot of times in Michigan, they're focused around the holiday with the automotive plants. They wait until that downtime comes, and then they do that stuff. And then the incident response plan, all those things need to be wrapped up into that. One thing that gets missed a lot in the OT space is having spare parts on hand. If they're mission critical things, they need to have some spare parts, even if it's old stuff, sitting on the shelf, ready to go, confirmed it works, so that they can get things back online. When you think like pipelines and stuff like that. So, okay, super fast talk. Yes, I hit the mark. Great. Thank you for coming.